Okay, great. Hey everyone, I'm here today to talk to you about Java asynchronous backend systems and RxJS libraries, which enable us, for want of a better word, to deal with streams of data. So, in order to first get started, I'm going to talk to you a little bit about what is a stream, um, and obviously a stream is a flowing river of events that constantly happen. So a stream is merely a list or collection that contains of elements, but these elements, rather than doing a for each on them, we're going to call one of the key aspects of reactive programming, which is called on next. So on next is a function that'll go and grab you the next element in the stream. And in order to particularly feel good about things, I'm going to give you a 5-second introduction to what a stream is. So a stream is merely a real life thing. So if I look out of the window and I see cars driving by on the highway, that's considered a stream. Essentially, it never ends unless there's some terminal event, like maybe there's a car accident, or maybe there's a roadblock or something. So the idea with streams are that streams are flows of data, and they could either be infinite or they could be a finite set of them. So to sort of illustrate this, I'm going to start showing you some yoga poses. Here's my first pose I did at 8 a.m. this morning. I now have the next one at 4 p.m., 8 a.m., 4 p.m., 8 a.m. I would do one now at noon. Wow, look at that. Noon, 8 a.m. I keep going. And yeah, maybe I get less encouraged, or maybe I pick it up again. And this is my stream of events. It's continual, it's infinite, it never stops. But you could think of it as an array. So if we put this puppy inside angle brackets like this, and we did commas between them, essentially I have now collected a series of events, and these constitute a list, which in reactive programming could also be considered an observable. An observable is a set of events that live in a list that could either be single or continuous. And then the beauty of reactive programming is that this list allows me to allow subscribers to subscribe to it. So essentially what we're dealing with here is the observable pattern. So I don't know how much any of you know about design patterns, but we have this concept called an observer and an observable. Okay, so we have these two very basic concepts, an observer and observable. In essence, we are talking about two kind of paradigms here. We're talking about pub/sub, publish, subscribe, right? The publisher is my observable X, my observer is Y. So my publisher is X, my subscriber is Y, Y, Y. I can have many. That's the pub/sub model. And the other model, of course, is the model view controller. And this is where it all started with Smalltalk back in the 80s with the Gang of Four Design Patterns book. But essentially there we get this design pattern, the observable, and we basically say, well, hang on a second, my model is something I want to observe. So in essence, it is my observable. And then typically my views are interested in changes in the data. So I might have view 1, which might be a histogram. I might have view 2, which might be a pie chart. And I might have view 3, which could be like a table of data. So in this case, in the model view controller, the model is the observable, denoted X. And then views are the subscribers, essentially. Views subscribe to the models, and they get the on-change event, And basically it's a pub sub. So every time the model changes, my view changes. And of course we all know about this in Excel. You change something in a data cell and your screen updates automatically in every graph you've done. So what we're seeing here, and in a nutshell, is the concept of declarative programming. So declarative programming is basically very different to imperative programming. Does anyone know the difference between a declarative and imperative programming? And yes, that could be a rhetorical question, but I'm going to tell you just because I'm making the video and no one else is listening. So declarative is you put the data in where you need it to be. It is the data, it is the behavior, it's a formula in Excel, it's data in a cell. Imperative would be take value 1, put it into row 2. So pretty much your standard programming language that 99.9% of programmers do, which is basically run through lines of code, line by line, conditionals, putting in formulas, etc. So we're going to kind of break this model. We're going to say enough of this. We're going to tear up this model and say, look, we are now going to move forward to this new idea, and that is reactive programming. And reactive programming is all about asynchronous programming and how you can create event streams, and these event streams can be observed, and each observer will get a notification when the data changes. The data can then be transformed in the observer, and then it then becomes an observable to another observer. So you create a pipeline event, and this is very powerful because this means now I can break my programming up into different threads. We don't really call them threads in reactive programming. They're more like concurrency containers. It's concurrency. It's about using the underlying multi-processing aspects of the computer. So these systems are highly performant. We're talking in the region of hundreds of thousands of messages per second, higher than any message queue on the market today. Maybe some custom message queues could do better than that. But in general, reactive programming, these are the fundamentals. This is what will get you to the next stage, and then we will start building in more reactive aspects. But for today's lecture, all we're really going to talk about are the operators on the lists, the observables. So how can we take data in the list? How can we filter it? How can we reduce it? How can we scan it, zip it? Basically, functional programming 101 made easy by using a reactive framework. And bear in mind, reactive frameworks do not need to be in Java. They do originate in C#. You can do it in all languages, whatever you like. So anyway, that's my introduction.